So now let's try running a computer vision model locally on the Meta Quest using Unity CentOS and the footage from the camera API. So I've already installed Unity CentOS from the package manager, and we need this to actually run the model. And I've got a model trained on the MNIST database to recognize handwritten digits from the ONNX model zoo. And I've downloaded MNIST 12 from here, which uses the ONNX offset version 12. So all I've done is I've dragged the ONNX file into the Unity project. And now what we'll do is click on Serialize to Streaming Assets. So that creates a new folder called Streaming Assets, and it's put the .centis version of that model into here. So now we'll go to the camera test script. And so what we have to do here is to first load the model. So what I'll do is I'll create a function to load the model, and I'll create a field so that we can set the path of the model file in Streaming Assets. And I'll say model equals that. So that means I'll make a field here, and that'll be assigned by the function. So now to load from the Streaming Assets folder, we'll have to use Unity Web Request. Android builds in Unity store the Streaming Assets folder inside the APK. So, and the APK is a zip file, so file won't be able to access it. So we have to use Unity Web Request. So for that, I'll do using Unity Web Request, request equals new. Now set the URI here to new system.uri, or you can just say URI and import it from system. And I'll do path.combine application.streaming assets path, and I'll put in the model path in Streaming Assets. Next, I'll create a download handler as a new download handler buffer, and I'll say dispose download handler on dispose as true. So now we'll just yield if the result of the request is not success, we'll say debug.log error and return, yield break. What we have to do now is create a temporary path, is path.combine application.temporary cache path, and I'll just say temp model copy.centers. Now we have to do file.write all bytes to this path and save the model to there. So do let me know if there's a better way of doing this, because next what we are just going to do is say model is equal to model loader dot load from the temp path, and now we'll delete that temporary file. So next what we have to do is we have to edit the model a bit to configure it to get the right output. So I'll put that in a different function. Now another thing I'll do is I'll make this a temporary variable. So model is equal to that, and I'll pass in this model, and this method will return the shape of the input, so tensor shape input shape, and also the actual compiled model. So digit recognition model equals that, and input shape equals that. So we'll create the function. So what I'll do is this is all code taken from Unity sample for the digit recognition model. So I'll do, so now we'll just return graph.compile probabilities, index of max probability, and the tensor shape. So we got the configured model now, and then what we have to do is create a variable for the input so that we don't have to create a new input every time. We'll also create a worker to execute the model. So we actually don't need a reference to the model. So now all we have to do is input tensors is equal to new tensor float, and in the input shape, digit recognition worker is a new worker for the model, and it will be running on the GPU. The texture will be a new texture 2D, the width 28, 28, in texture format ARGB32, MIP chain as false. That's the model setup. So I've set this as ARGB32 because that is the same format that is used by the texture converter. So if I go here and see where frame render texture is initialized, it uses ARGB32. So now I'll also put in a new preview image that is for the model input, and we'll set the texture of that as input texture, and we'll just add in a few logs. Now when we get the camera image, I'll add a callback. So this will be called every time each camera frame has been converted from YUV to RGBA. So we'll add the callback to start inference on the model right there. So create a function, and I'll add a Boolean flag. So I'll check if it is busy, and if it is, we'll just ignore this frame, and then we'll set that immediately. So this is so that the model doesn't try to compute two images at the same time, right? And in the end of the function, I'll set this to false. So now I'll have to create a function to copy the contents of this render texture to the input texture. So I'll implement this function. So first, this requires that render texture dot active be set to the input render texture, right? So we'll store the previous active render texture, if there are any, to the one that was active before we set it. So in the end of the function, we can reset that. So now all I'll have to do is call input texture dot read pixels, and I'll create a new rect to read the pixels from. So this will be the point from this render texture where this input texture will read from, right, to copy. So I'll say the x for that, where is that? Yeah, the x would be render texture dot width divided by 2. So that gets the center of the width, right, the center of that, and subtract 14 from it. So this will get the point in the render texture from which we have to start copying into the input texture. And since the input texture is 28 pixels, we subtract half of that to get the correct starting position. Now all we have to do is copy this and do the same with the height. Now the size to copy from will be 28 by 28, or we can do input texture dot width input texture dot height. So now this will work for whatever resolution input texture is in, and we'll in the destination we'll just put it as 0 and 0. So now we have done that, we have got the copy, and we'll send this to the GPU. So now what we have to do is texture converter dot to tensor, and we've got the input texture. We'll pass in the input tensors and create a new texture transfer. So now we can schedule the worker to work with our input tensors. So that'll start inference. So what we'll do is a tensor probability worker dot up 0. That'll get all the probabilities for each number. So that gets the first and second outputs, which we had configured earlier in this function. So now this is a blocking call. So if you're on, so I'll put an if here, Unity 6000 or newer. I'll put else here and so I'll copy this and say async. So this will do the same thing but as an async call, right? So I'll put an await here. So what I'll have to do is again sync void. So that's done, and this has to be an int. So I'll correct that here. So that's it. So now what I'll do is I'll create a text field so that we can output the result on screen. And I'll set that here. That's it. And what I'll do is in the streaming assets, I'll copy the name of this model and I'll put that here and put it as .centers. And the last thing is I'll create a new raw image. So I'll rename this to camera preview and I'll create a new image. So that'll be the model input preview. Pause that here. Oh. Yeah. And I'll create an output text. Okay. I'll also make it white so it'll be a better contrast with the camera feed. And now we can build it. So I've put the build on my Quest 3 and let's try it out. Okay. Okay, so on my laptop screen, I have a few numbers. So let's try to focus the camera on one of them. It's quite hard to focus because the area is so small. But once you get it and stable, you get predicted 6. Now let's try 3. There you go. And yeah, so let's try 0. Yeah. So that's it. We've got a model running on the Quest 3 detecting numbers. So thanks for watching the video.